Alright, so welcome to Chapter 3, Section 4, called Slope-Intercept Form. This is for Math 8. So just as always, I'm going to go over a few things on the screen here. So the first thing you should see is a due date on your student's screen. We should always be able to see when the homework is due, or whatever task you're working on. I don't see that on the teacher preview, so you don't see it here. Attempts is the second thing we'll see on the screen, so I'm on attempt number 1 of unlimited attempts. I can come in and try this assignment as many times as I would like. It doesn't matter how many times, I can just keep on coming in and trying over and over again. Number of questions just tells you how many questions there are on an assignment. There should be anywhere from 1 to 10 questions on an assignment depending on how many topics were available. This one was accidentally assigned 13. We can't go back and change it now that it's open to all the centers. So this one just is going to have a couple extra questions on it. Grading policy is best score. So that means whichever attempt is the best one is the one you get to keep. Partial credit is enabled, so if you answer one of the 13 questions, you get credit for that one question. This last part here just says, please remember once you start your homework, you must finish it before you can work on anything else. So once we click Start here, on the bottom right-hand corner of your screen, you should see a Submit Assignment button. You always click Submit Assignment when you're ready to leave the screen. Don't just close the screen or log out, because then the system is going to assume you want to keep working on this attempt instead of submitting it. Number 1, that locks you out of all of your other assignments. You can't work on anything until you come and submit this assignment. And the second thing is, it also doesn't let the teacher know that you've been working on it. It doesn't show us anything about it until you click submit. The only thing we might know is that you've been sitting on the assignment, but we don't know what you've done inside of it yet, not until you submit it. So just keep that in mind. It's a very quick way to actually change the gradebook too if you haven't submitted an assignment. So fill in the table. Before we get there, let's go over these pieces. So we have explanation, example, and message center. So explanation, that tells me I'm going to lose my question attempt because it's quite literally going to explain this question to me. So it's not going to give me an example, it's going to actually explain this one. It's going to give me the answers. So it's not going to give me the answers and then let me come and type them in. It's going to have me come in on another attempt to do that. Example does in fact give me just a general example, but it's an example of this problem type, so it's very helpful. So I can see here's an equation just like I have on the other page. Here's a table just like I have on that other page. And I can see what it's asking me to do is here's an input. It's putting it in here for x. We're working out using Pemdas, so it's multiplying the -5 and the -1 to get +5, bring down the +3, and then we add them together and we get 8. And that's the output. So when x is -1, y is 8. And we're going to do that for each piece. We're going to fill all of them in. And then we, have our finished table here. So it's just creating an XY table. You can also message your teacher directly from this screen, and it will actually attach the question to the screen so that we know where to come help you. All right, let's go ahead and start this off. So what I'm going to do, we have y equals -6x plus 3. And we're being asked to input these 4 amounts. So what I'm going to do is I'm going to go through and I'm going to fill this out really quick, because this just makes it easier. I like to put these in different colors so that you can actually see what the input is and what the output is. So if you notice, I'm just writing the exact same equation 4 times. So this is the same exact thing. Sorry, these are supposed to be plus signs. What I'm going to do is I'm going to go through and I'm going to fill it in. For the first one, I'm going to put -5 in here. For the second one, it's -1. For the third one, it's 0. And for the last one, it's 1. So now I'm going to start to work this out using Pemdas. So I do my multiplication first. -6 times -5 is 30, plus 3 is 33. And then I have so this is actually the first answer here. So let's go ahead and type it in, 33. Sorry, that went very quickly, didn't it? So that's my output. If x is -5, y is 33. So for the second one, I have -6 times -1. That's +6 plus 3 more. So 6 plus 3 is 9. So if x is -1, y is 9. Come on, go over there. Let's go and do that. Okay, so let's go here and go -6 times 0. Well, that's going to get me 0 plus 3. So 0 plus 3 is 3. So if x is 0, y is 3. And let's do that last one. So we have -6 times 1. Well, that's -6 plus 3 So negative 6 minus 3, these are opposites. I'm going to subtract. 6 is bigger, or it has more. So there's more negative than positive here because 6 is bigger than 3. So it's negative 3. So just be careful about those integers. I'm subtracting them, and the bigger number helps me decide my sign. So if x is 1, y is negative 3. All right, so that's just filling out an XY table. It's telling you what to input for x, and you work it out to see what you'll get for y. All right, next we have find an ordered pair that is a solution to this equation. So with this one, they're not telling me what to plug in, are they? I have to decide, what am I plugging in here? And you can decide anything at all, anything you would like to plug in. It doesn't matter. Alex doesn't care. I can plug in 1,000,000 here if I would like. So I'm just going to choose a number, and I kind of like 0 because 0 is really easy. So I'm going to plug 0 in for x, like this. Because 0 tends to eliminate something, because anything times 0 is 0. So that's why I like to pick it, because it eliminates something. So 3 times 0 becomes 0 minus y equals 3. Well, I don't have to, 0 minus y is just negative y. Remember that negative belongs to the y. Well, I don't want to know what negative y is, so when I end up with a negative variable, I'm going to give that negative the other side. It's the same idea as multiplying or dividing by negative 1. So it's in fact what we're doing. It's just kind of an easy way to think of it. I'm just giving it to the other side there. So my y becomes positive. My 3 was positive. Now it's negative because I gave it that negative sign. So if it was negative, it would have flipped positive. So be careful that those positives and negatives still matter. So we have 0 and we have negative 3. This is not the only solution to this question. In fact, there is an infinite number of solutions to this question because I can pick any number I would like to plug in for x. There is no limit here. All right. So the next one, it wants me to graph. So if we've never seen y equals mx plus b before, because 8th grade, I think this might be the first time it's introduced. I'm trying to remember back to 7th grade. It's been a little while since I've taught 7th grade. So I don't remember if we actually introduced this formula in 7th grade or not, but what they're having you do is they're actually still having you look at an XY table. So they're still having you plug in some pieces. So with this one, we'll write out the equation and we're going to plug in some pieces. We're going to get to slope-intercept form in just a moment because that's the title of this section. So we will start to look at the qualities here. And this is actually the slope-intercept form, this y equals mx plus b. And I'll explain what that means when we get to that screen where they actually want us to start using it. So let me erase this really quick. Okay, so we're going to go with blue here. So we have y equals negative 3x minus 2. So we need at least 2 points. I sometimes suggest going to a third point to make sure that you worked this out correctly, but 2 points is all you need to make a line. You need a beginning and an end. And it's not truly a beginning and end because it actually keeps going past those, but you need 2 points to connect so that the program knows where to go. So picking some small numbers, is perfectly fine. Be careful about the size numbers you're picking when you're graphing because you're limited by the window here. So if I go bigger than 10 for x, I can't graph it because it only goes to 10. It's not that it's a wrong answer in any way. I just can't graph it. So be careful about that as far as the size of the number. So the smaller numbers you choose, the better. So we have negative 3 times 0 is 0, minus 2. Well, 0 minus 2 is just minus 2, right? And I wasn't bringing these down. So this is going to be the coordinate 0, because we chose 0 for x, and negative 2. So here's my first coordinate, and I can even come over here and start graphing this coordinate. So I can go 0, I'm not going to go right or left, but I am going to go down to 2. All right, and then I'm going to come over here and go y equals, so negative 3 times 1 is negative 3, minus 2 just comes down. Negative 3 minus 2 is negative 5. So this coordinate, I chose 1 for x. When x is 1, y is negative 5. So there's my second coordinate. So I'm going to go back to 0, 0, and I'm going to go over 1, because it's right 1, positive 1, and then down 5. Now I can click on my line tool and go click, click. I can actually do this without placing the points too. This will place points for you also, but it's nice if you already have the points placed and you know exactly where to click. Alrighty, so we just graphed a line. Woohoo! So we're going to take a look and let me see, are they starting to introduce it to us yet? Not quite yet. So we'll get there in just a moment. So now they're looking at a fractional form here. So this is another piece. It's just another form of the same line. So we have y equals -4/3 plus, x plus 1. So again, we need to choose two amounts for x because we need at least 2 points. So I like to do, and I'll just put these over here because we're going to write this out. So I like to do 0 and 1. So 0 and 1. And then we're going to figure out, all right, well, what is y when x is 0? Well, anything times 0 is 0 plus 1. So that means y is 1 because plus 0 doesn't change it. So there's my first coordinate. I have 0, meaning I'm not going to go right or left. But y for 1 means I'm going to go up to 1. All right, so now I have y equals -4/3 times 1. Well, that would be -4/3 plus 1. So now I'm dealing with a fraction issue here. I'm going to have to add or subtract these fractions. Remember 1, I can change this into a like fraction. If there are 3 pieces for every whole number, that means there are 3 pieces here. So it's 3 out of 3. So this is just converting it really quick. 3 divided by 3 is 1. So I just converted it to a fraction so that I can actually subtract these really quick. So -4 plus 3, well, that's -1 over 3. So if x is 1, y is -1/3. So I can't graph that with this pencil tool. If I go over 1, I can't go up 1/3. It bounces in between 0 and 1. I can't actually stop in between. So when I have a fraction or a decimal, what I need to do is go to this point here, and it actually has 1/3 as an example. So I'm going to go 1 for my x, that's what I chose, and it's -1/3. So if you notice, it's actually putting it there already. I can see that it's there. If I don't click plot point, it'll disappear if I close this. So I want to make sure I click plot, and now I can close it. So now I have my 2 points, and I can connect these 2 lines. And it'll let me click on it now that it's actually plotted. It wouldn't have let me click on it if it wasn't there. So that is my graph. Ta-da-da! All right. I think it should give me a little noise when I get that right. Ta-da! I think that'd be awesome. All right, are they still asking us to do a table here? I think they are. They are, okay. So we're still working on tables for a minute. Okay, so we have 4x plus y equals 8. And I'm flipping my colors here, but we're going to need 2 points, at least 2 points, to make a line. So now we have red and blue switched, but that's okay. So again, I'm just going to do 0 and 1, just so that they're very easy coordinates to pick. Are those the only coordinates I could pick? Of course not. You can pick a whole lot of other coordinates from there. So we have 4 times 0 is 0, plus y equals 8. Well, plus 0 doesn't mean anything, so it's just y equals 8. So if x is 0, y is 8. So that's our first one. So we'll go ahead and work this out, and then we'll plot them both at the same time. 4 times 1 is 4, plus y equals 8. Remember, I want to know what y equals, so I need to take this plus 4, and I need to subtract it from both sides. I need to solve for that variable. 4 minus 4 cancels, so y drops down by itself. 8 minus 4 is 4. So if x is 1, y is 4. So let's go ahead and put this on here. So 0, positive 8. So I didn't go right or left, just straight up to 8. And then the next one is 1, 4. So positive 1 to the right, positive 4 to the top. And I've actually done this too before where I'm using arrows. So there's no arrow here, but with this one I would go straight up. And then with this one I'd go right 1, up 4. Remember, it's a direction system. That's all this is. So if I'm standing here, let's say we're in the middle of a city, and I'm standing in this point, and I want to get to this spot here, I can't go through the buildings. We're going to say that's not allowed for right now. So what I need to do is I need to go over 1 block to the right, and I need to go up 4 blocks to get to this point. So it's just a direction system. That's all it is. It's just telling you where to go. All right, let's go ahead and connect these lines here. Okay, check. And we are good to go. So continue. All right, Anne purchased N notebooks. They were $5 each. Write an equation to represent the total cost C that Anne paid. All right, well, the total cost is going to equal the amount she spent on books, right? Notebooks. I'm just going to call them books for now, okay? So total cost is the number of books she bought. And that's going to be the number of books times the dollar amount that they cost. Does that make sense? Hopefully that makes sense. You know, the amount of money that it costs per book, we would multiply those together. So, and I'm holding a pencil right now. If I buy 1 pencil that's 10 cents, I'm going to pay 10 cents. If I buy 2 of them, they're 10 cents each, so it's 10 cents times 2, which would be 20 cents. So I can use multiplication there. I can use addition too, but repeated addition, we learned in elementary school, we can write that with multiplication, right? So instead of having to say she bought, 20 books and say the cost plus the cost plus the cost plus the cost, I can take the cost and multiply it by the number of books she bought, instead of trying to do that repeated addition. So instead of the word cost, they want us to use the letter C. They asked us to do that. And then they told us that the cost was $5. It's $5 for each book. And she purchased N notebooks. So instead of number of notebooks, we have N. So the cost is going to equal N times 5. Or 5N. We would write this C equals 5N like that. Because that's how you multiply a variable and its coefficient. You just put them together like that. So C equals 5N. Check. All right. Trucking right along here. We're halfway through. Okay, so for this one, they're just telling us graph the line with the slope -3 and y-intercept of 6. So with this one, we need to definitely understand what y-intercept is and what slope is. If we don't know what these two pieces are, we're not going to be able to complete this problem. So an intercept, when we're talking about that in math, if you've ever heard it from maybe football, an interception is when the other team catches the ball, right? So a y-intercept or an x-intercept, when we're doing this in math, is where the axis catches the line or where it crosses the line, okay? So the y-intercept, we simply go to the y-axis, and that's where the line is going to cross. It's going to cross at 6 right there. That is a point, and that is actually our starting point in this case. So we start at the y-intercept, and then from there, we work on the slope. And I know we've talked about slope quite a few times in the last few weeks. So slope is rise over run. Slope, I don't know what I was spelling there. My goodness, I'm just losing my crazy mind here. Slope, and we have rise over run. Run, geez Louise, I'm just losing it here. Rise over run. They told us that the slope is -3. So when we have just an integer like this, we need to remember that all numbers have a 1 under them. It's there because dividing by 1 doesn't change anything. So we just need to keep it in mind that it is there so that we know what the run is. Because otherwise we're not going to know where to go. Well, -3 will rise over run. Which one is it? Is it rise or is it run? Well, in this case it's rise because the integer that you see is always the top number, the numerator, and the denominator is going to be 1 if you don't see a denominator, if it's not a fraction. All right, so we're going to go down 1, 2, 3 because it's rise of -3. I know we call it rise, but we're falling. And then we're going to run 1. So since it's a positive 1, we go to the right one. So down 3, right 1. So this, we're going to go down and right. Again, it's just more directions. It's just a direction system. That's all the coordinate grid system is. All right, so we have our slope and our intercept, and there we go. So I'm assuming on the next one here, it's going to start to introduce this equation to us that uses these two pieces. All right, perfect. So find the slope and the y-intercept of this line. So if we look at the explanation, they should start to introduce this to us. So we have slope-intercept form here. And I'm going to go ahead and leave the, well, I'll leave some of it here. We don't necessarily need that piece. But we do need to know what slope is. So we have y equals mx plus b. I'm even going to change this to red here, just so that it's kind of in a different color. And then I'll change this to green. Sorry, I'm being all sloppy here. So m stands for our slope. That's the variable we use for slope. So we already know slope represents rise over run. And b, so that's the new term here. This is our y-intercept, the thing we just dealt with where it crosses the y-axis. So we have our two pieces. If we know this equation, we can very quickly pull some information out of it, as long as it's in this format, if it equals y. Well, now my slope is next to the x, so the slope of this line is -3/2. And then my y-intercept, which is my starting point, that's always where we start when we're graphing, that's going to be the number that's being added or subtracted. And when I start, I go to the center and I either go up to this number or down to it, depending on if it's positive or negative. I'm not going to go right or left. It's a y-intercept, meaning it's on the y-axis. But I can very quickly pull these two numbers out of the equation and immediately start graphing without having to do an XY table. So it's just a very easy way, if we have it in this form, for us to be able to pull numbers. So if I'm looking at this and I have y equals mx plus b. So remember, the slope is next to, and I'm going to change this. I'll do the same color coding I did here. Y equals x. So in this one, our m, the number that's next to the x, is 2, and our slope is -6. Sorry, not our slope. Our slope is the 2, the blue 2. Our y-intercept is -6. So I can very quickly match this up. Whatever number is being multiplied by x, that is my slope. Whatever number is being added or subtracted, that is my y-intercept. So my slope is 2 and my y-intercept is -6. All right, let's go ahead and keep moving here. We're almost through this one. Okay, so in order to do this one, we do need to change it a little bit. We need it to equal y in this one. So we can't just simply start using this one until we make it equal y. So I'm going to bring this down here. 9x plus 3y equals -3. So I want to solve for y. So I'm going to start moving things away from it just like I normally would. So 9x is being added. I'm going to subtract it from both sides. 9x minus 9x is 0. Any number minus itself is 0. 3y equals -9x minus 3. I can't combine those because if we're paying attention to Pemdas, 9x is being multiplied. So I have to do that multiplication before I could have subtracted that 3 from it. So those are not like terms. I can't combine them. I can divide by 3. Keep in mind I have to divide everything by 3, not just a piece. Every piece gets divided by 3. So 3 divided by 3 is 1. -9 divided by 3 is -3x. -3 divided by 3 is -1 instead of +1. All right, so now I have my y equals x, and I can see the number that's in front of the x is -3, and my number that's being added or subtracted is -1. It doesn't matter if it's out of order. If the number being added or subtracted is first, and then you have your coefficient x, which coefficient is just that number in front of x, doesn't necessarily matter. What we're doing is we're looking for those pieces. So even if they're a little out of order here, as long as it says y equals, we're still okay. We're always looking for the m that's in front of the x. It's being multiplied by the x. So it doesn't matter if it's first or second, okay? So we have a slope of -3, and we have a y-intercept of -1. All right, let's keep on moving. Okay, so in this one, they actually just told me what the pieces are, didn't they? So they write an equation in slope-intercept form of the line with slope 1/4 and y-intercept -3. All right, well, I flat out was just told slope and y-intercept. So we're going to have y equals, it's the slope times x. So they told me slope is 1/4 x, and then it's plus b. In this case, it's -3 because we're subtracting. It's a -3, so plus b becomes -3. So I just plug those two pieces in, right? So I can come over here just to make that a little clearer because I didn't write this out. Equals x. They told me that my slope was 1/4, and they told me that my y-intercept was -3. So I just simply plugged those in and wrote the equation out. I know it was going to be y equals with an x there. I just needed to fill in those other two pieces. All right, let's keep going here. A couple more. We're getting there. Okay, so we're going to do this off of a table. So a table of values of a linear function is shown below. Find the slope and y-intercept of the function's graph, then find the equation for the function. So slope is rise over run. So what I need to do is determine what are these changing by. So my run is the x. So each time I'm looking at this, it's going up by 1. So I'm going to come up here real quick and I'll change this to blue. So this is going to be, we're going up by 1 for run. And then if I look at y, that looks like I'm adding 4. I know it's going negative, negative, but I'm getting closer to 0. And then -2 and +2, well, that's a jump of 4 again. 2 to 6, that's an easier one to see. We can definitely see that's going up by 4. And then 6 to 10, we can see it's going up by 4. So my slope is going to be 4 over 1, or just 4. So I'm going to go ahead and write that here, 4. So we have y equals x. We need to know what is our y-intercept now. So I can go ahead and put 4 in here for my slope. My y-intercept, if we think about the coordinate grid, right? I'm thinking about the coordinate grid here. We want it to be on the y-axis. If it's on the y-axis, then x has to be 0. I'm not going right or left. I'm going up or down. But I'm not going right or left at all. So what I want to do is I want to look at my table and find where x is 0. And that is my y-intercept, because it has to be on the y-axis. If x is 0, then it's right there on top of that y-axis where I want it to be. So my y-intercept is 2. So it's going to be +2. So there we go. I wrote the equation as we filled this in. So all I have to do now is write this in here. Y equals 4x plus 2. And we are golden. Uh-oh, don't freeze on me, please. Come on. You can do it, computer. I gave it a few seconds earlier when it did this and it reloaded. I might just have to reload the screen. Well, it doesn't look like it's going anywhere. Okay, I'm going to go ahead and reload the screen just so that we don't have to wait for it here. In my case, it's going to completely reset and take all of these away. Okay, so we'd already answered that one. It just didn't give us the points and you can see it took all of my check marks away. It will not do that to you as a student. It will definitely save your progress. It doesn't do that for the teacher preview. No matter how many times I come here, it's always my first attempt. When I come here, you can see this is actually the second time I've clicked on it, but it still says attempt number 1. So it just doesn't save that information for the teacher, but it does save it for the student. So let's go ahead and go to number 12. All right, so we're going to do the same thing, but we're going to do it off of the graph now. So let's go ahead and, I should have erased all that. Oh, we can leave some of that. Okay. Sorry, I'm just losing my mind here. Had to reset the internet. That throws me off a little bit there. All right, So we're going to grab two of the same things we always need, y-intercept and slope, as far as right now. When later, we're going to start to learn other forms of a line. But right now, we need these two pieces to write it into an equation. So we're always going to have y equals x. And we need to fill in our slope and we need to fill in our y-intercept. So y-intercept is really easy to fill in when you have a graph or a table. On the table, you're looking for x is 0. If you're on a graph, you're literally going to the y-axis here and saying, okay, where does it cross? In this case, it crosses at 0, so we'd have plus 0 here. The slope, we can either calculate this using the slope formula, which we learned in, I think it was 2 sections ago, and we've used that quite a few times before. Or if you have a graph, you can just simply count this. It's the change in y, so how far do I have to go to get from one point to the other vertically and horizontally? It's the change in y over the change in x. So 1, 2, 3, 4, 5, 6. I have to go up 6 and 1, 2, 3. So I have to go up 6 and over 3 to the right. I need to reduce this because I can't leave it like this. So I can divide both of these by 3, right? I can reduce this fraction. So I'm going to have y equals, and instead of 6/3, I'm going to have 2 over 1. Do I really need to put 2 over 1? I don't. I can just say 2. I also don't need to include plus 0 because that's doesn't change anything. So that's another thing. If I don't see a number being added or subtracted, it doesn't mean that the y-intercept doesn't exist. What it means is that it's going through 0, 0. So it's going right through the origin there is what that means if I don't see this y-intercept on my equation. All right, let's go ahead and click check and continue. Okay, we are on our last one here. So let y represent the total cost of publishing a book. Let x represent the number of copies of the book printed. So we didn't get any kind of story here. It just started giving us some information. But if we kind of stop and think for a second, I'm sure we can figure out, okay, well, it's talking about cost of publishing a book, copies of a book. I can figure out, okay, I must be printing books and it costs me money. So we can kind of put the story together in our own head. Suppose that x and y are related by the equation y equals 1,150 plus 25x. And then we're going to answer some questions down below. So we have this equation, y equals x. So in this case, and I'm going to rearrange it a little bit because it said 1,150 plus 25x. So I do like to see my x term first. It doesn't matter if I move it first or if it's second, but I just like to see it that way so it matches up nicely. Plus, not minus. So here are my two pieces. So I have my equation, and I color-coded it there so we can kind of see very clearly what it means. So remember, the y-intercept is our starting point. I've said that quite a few times even in this video. So if that's our starting point, then our starting cost must be this amount here. That's where we start, no matter what, for what we're doing for the books. That's just the cost of getting all the machines and material together. And then we have this 25x, and it told us that x represents the number of copies of the book. So if x is the number of copies, and we're multiplying by 25, and we're talking about cost, then that must be the cost per book. So that's just another thing, we're just breaking down this problem. That's my slope. That's what it changes by with every book I print or every copy we make. All right, so let's go ahead and look in there. These are very direct questions from what I just said. So what is the change in the cost for each book printed? So we literally just talked about that. For every book I print, which is X, it's going to cost me an extra $25. So it's $25 per book. What is the cost to get started before any books are printed? So like I said, the y-intercept is our starting point. Always, always, always. If we can identify that, that gives us our starting point. So it's going to be 1,150 or 1,150. And it might give me grief if I don't put the comma in here too, especially when we're talking about money. All right, so we are all done with section 4. I will see you in section 5.